After studying this module, you shall be able to know about various technology of printers. You will able to identify the printer technology with the help of identifying features that will help a forensic scientist to identify whether they are similar or not. One of the most extraordinary skills that we as a human being possess is return communication. Unlike a conversation, our return words allow us to transmit idea not only over a distance but also over a time. It would seem that the urge to make a record of our lives as old as a man himself, even before there was writing or charcoal drawings in caves, show our ancestors recording important daily events such as particularly successful bison hunt, creating perhaps the earliest form of textbook, or then again maybe just bragging rights. Our progression from pictographs to graphical user interference has taken place over a remarkably short time. At no time in man's history, however, over the documents we make and print gone through more dramatical technological changes than in the past 30 years. The ephemeral world of thoughts has been transformed into something tangible using the equally ephemeral electrical charges held in a silicon memory register. Our ancestors would have understood why we want to tell a story, but they could never have imagined how. To quote the famous science fiction writer Arthur C. Clarke, that any sufficient advanced technology is indistinguishable from magic. The history of recording our thoughts in printed form is also the story of mankind's changing technology. At most every major technological advance, there has been a corresponding change in the way we record and store our ideas. Certainly, some of the earliest attempts at industrial chemistry and technological innovations came from the efforts to make a better inks and dyes. The adaptation of movable recast-able hot metal type in the late 16th century helped to spread literacy across Europe. During 17th and 18th century, metallurgists gradually learned how to increase the strength of iron and steel. The typeface designer quickly took advantage of the harder metals by creating new type fonts with fine detailing and smaller size. Because of the greater readability of these newly created alphabets, more letters would be strung together on a page, thus saving the paper and ink cost for the printers and publishers. As the printing costs were reduced, the distribution of the printed words on pamphlets, flyers, and of course the books began to spread among the population. The information technology of the day continued to move in a lockstep with general technological innovations. Now let us learn about the computer generated documents and forensic examiner. In the late 60s, it was considered mandatory in the field of question document examination to read Ordway Hilton's or Dr. Philip Beaufort's and Dr. David Cron's treatise on the examination of typewritten document. At that time, the business community was just upgrading their typewriters from manual and electrical signal font machine to the new IBM Selectric typewriters with interchangeable type elements. For the first time, the identification of a typewritten element or document requires the identification of a typing system rather than just the typewriter. Since the defects could occur on the type element or in the typewriter itself, it becomes necessary to contend with the fact that an element could be moved from machine to machine or a machine could use multiple elements. It was therefore the combination of typewriter and interchangeable elements that was identified as a system. In the space of just 40 years, we have gone from the Selectric arguably the most technologically advanced typewriter of its day, to computer age. A document creation system that had just two parts in 1961, that is a typewriter and element, can now have a multiple components, some based on the software and some in the hardware. The modern forensic document examiner must be aware of such things as the operating system, the word processing program, the version of the word processing program, the digital font and the version of font file, the printer driver and its release date, as well as connection to the printers. All can have an impact on the appearance of printed text, as can the many variables associated with the printer itself. Make no mistakes about it, this is a complex area that requires some knowledge of typography, digital fonts, computer system and software. All of these topics could fill their own textbook. This particular modules provide a boiled down version of what is believed to be the most important information for those engaged in the forensic examination of computer generated documents. Now let us proceed with the examination procedure. An examination will often be conducted to help answer the various questions that are at issue in the cases, like, is the document an original or a copy? Can the printing technology be identified, that is, they can be dated? Has more than one technology been used to prepare the document? Letterhead printer on a lithographic press, the variable data printed with the dry toner. In a multiple page document, is there evidence that one or more pages are prepared differently than the others? Is there any evidence that text has been altered or added to the document? Are there any obvious defects in the printing that might lead to the machine being invisibilized? In general, the well-established principle that documents should be thoroughly scrutinized on both the sides, corner to corner, is just as valid for modern computer-generated documents as it has been since the dawn of the forensic science examination. Now let us learn about the identification features of the printing process. First, we have the high-speed mainframe line, drum and chain printers. Output from these printers is more likely to be found in the historical cases rather than on the more modern documents. If the document itself is printed on the tractor-fed green bar paper, there is a good chance that it was printed on an impact printer such as dot matrix or one of the high-speed printer. The typical line printer's output is monospaced, that is 10 characters to the inch, with the older printer utilizing all capital letters. The newer line printers, however, could use a full upper and lowercase alphabet, with Courier being one of the font options. The letters themselves are solid form like the typewriter character, and also like typewriters were pressed through an ink ribbon in order to form the text to the paper. Although the characters may appear to be made up of tiny dots or dashes, this is an illusion caused by the weave of the ink fabric ribbon. Then we have the next class, dot matrix printers. Because dot matrix printer utilizes an impact printing process, they are often used today in setting where carbon or carbonless, that is NCR forms are printed. Hospital records, cash register receipt and text forms are typical kinds of documents created on a dot matrix printers. The most common pin array found in dot matrix printer are 9 vertical, 18 vertical as 2 columns of 9 and 24 pins as 2 vertical columns of 12. Then we have the inkjet printing technology. Inkjet printing comes in the two variable or two varieties, continuous drop and drop on demand. All of the modern desktop inkjet printers are of the second type, that is drop on demand. It is likely that most of the question documents that are encountered in a forensic laboratory will be from this type of inkjet printers. In commercial high-speed applications, however, the continuous drop printers are more likely to be found. Packaging, barcoding, bulk mailing and lottery tickets are some of the common applications for the high-speed continuous drop printers. Now let us move to the monochrome and color laser, that is LED printers. Both black and white and color laser LED printers utilizes dry toner as their ink. Keep in mind, however, that black and white and color copiers also utilizes toner. Although some older xerographic machines used pressure roller to crash the toner into the paper fiber, modern machines use heated fusor rollers to melt the thermoplastic binders mixed with the toner. As a result, some xerographic printers will produce images or text that have a glassy, melted appearance. Many of the newer microfine toners, however, have a the defects that may be observed in the fax document is a vertical black line or printing void resulting from malfunctioning of sending machine's scanning head. A similar feature may be consequence of a malfunctioning in the receiving machine's printing system. Another example is an incomplete image resulting from crumpling of the originals by a faulty transmitting machine paper fed system. A related defect is the consequence of receiving machine's fed mechanism failure to properly scroll the sheet, causing a horizontal portion of the image to be lost, obscured or elongated. The printing apparatus of modern fax machine utilizes the technology found in inkjet, bubblejet or laser printers. As a result, many of the defects that manifest themselves in these printers will also be found in the product of Fascimile machines, particularly when they are multifunction devices. The condition of TTI or RTI as well as the nature and positioning of the defects provide insight into whether the characteristics observed originated with transmitting sending machine. For example, a vertical band void breaking all printing on the page except the TTI must result from the defect in the sending scanning machine. Similarly, a vertical black line running the length of the image area is likely the result of an obstructed scan element, such as when an opaque fluid is transferred to the sensor during the scanning. By contrast, if the same vertical line extends the full distance of the page exceeding the image area, it could indicate the malfunction of receiving machine's printing mechanism. Other characteristics of identifying the value can be found in traces left by the feed mechanism. These marks are similar to those found in photocopies and computer-generated documents. They can be in the form of small black smudges on the reverse side of the page or appear only as indented impression detectable through indentation analysis. Now let us recall what we have learned in this module. Dot matrix printers are technically described as impact matrix printers. This distinguishes them from non-impact matrix printers such as inkjet, thermal printhead and even laser, all of which create text and images as a series of closely spaced dots. The thermal wax transfer printers functions by melting a wax-based resinous ink onto the paper. As the paper and wax coated ribbon move beneath the thermal printed head, heated resistance melt the wax onto the paper. Both black and white color laser, that is LED printers, utilizes dry toner as their ink. Dry sublimation printing is often used to produce photographic images from digital capture devices. Dye sublimation printers are often utilizes the produce identity document, that is both genuine and counterfeit. Fax copy forms small black smudges on the reverse side of the page or appear only as the indented impression detectable through indentation analysis.